Now recall that I chose not to implement IEquatableT on my classes. I'll now show you why I chose not to. If we look at the food base class, let's go ahead and implement IEquatableT. I'll ask Visual Studio to implement the interface for me. And we now have a strongly typed equals method. What can I put in it? Well, we have the same inheritance versus type safety issue as we did for the equality operator. The only thing I can do which will make this work correctly is this. Call objects.equals to make sure I'm calling something that's virtual. I mustn't put any equality logic in the strongly typed method itself, because that will lead to the same bug we saw earlier with the equality operator. So that's fine. But what have I gained by implementing this interface? Almost nothing. Unlike the equality operator, this method doesn't give me any nice syntactic sugar. I do now have a type-safe equals method, which is nice. But the trouble is there's no performance benefit for using it. Calling this method will be slightly slower than just calling objects.equals directly. So by trying to implement the IEquatableT interface, we've made our class more complicated for almost no benefit. So that's why for a reference type, I would almost never implement the IEquatableT interface. Think of this interface as good for value types, and you won't go wrong. There's one exception to this, which is that the interface can give a marginal performance benefit for sealed classes. Let's look at that next.